Hello, good afternoon all. I'm Sugandhi. I'm host for this event. I would like to welcome you all on behalf of Pioneer Business Solution. Thank you all for joining. Uh, People are yet to join. So before diving into the webinar, I would like to give one small introduction about us. So what we are and what we do. I'll be sharing my screen. Yeah. Yeah, we are Pioneer Business Solution and Engineering and IT Solution Consulting. And this is our glimpse of L&D and services. And we do end-to-end learning solution with virtual instructor lead training and classroom instructor lead training. And we do provide the services on Cloud Lab solution on across the technology. And we are proactively approach towards problem solving solution. We will understand the client expectation and will be providing the solution accordingly. And we do have more than 1,500 tried and tested trainer data with us, and we have a consultant, uh, signed consultant, freelancer consultant who have more than 8 to 20 years of experience. Thus, and we have excellent training coordination. We have internal team who will be coordinating everything, and we have trained more than 10,000 participants across various cutting edge technologies. And we do support this. We are the corporate training will be supporting all the across the globe. So this is our footprints, corporate training, information technology, mechanical engineering service, civil engineering service, and we do support on cloud labs, cloud services and HR services. And this is our different modes. So instructor lead training, instructor lead classroom training, and instructor lead, it's a virtual instructor lead training and hybrid learning. And we have different modes. So I would like to give few minutes of your time to explain bit. So we have instructor lead training. So we'll be having this will be a classroom training, and we have a virtual instructor lead training. So it will be this training will be providing it virtually wherever the participants can be take this training. And we have a hybrid learning. We will be getting all the modes in the we'll be getting a package of modes in the same hybrid learning. So we have a e-learning, and we have a mentor on demand and open house. Mentor on demand, where we will be after going to the training on virtual platform or else e-learning. So the participant might be having few doubt clarification session. So at that time we can provide the trainer who are expertised in that particular technologies, and we'll be giving mentor on demand on this. So we have open house batches. So in the industry, you might get the batches as per 8 to 10 participants as a batch. So we are play a very vital role here. So we will provide the open house modes. We'll be giving the less than 5 participants also. We can 3 to 5 participants. We can provide this open house batch. And this is our offering. So campus to corporate, core competency development and project consulting, and soft skill and behavior development program. So soft skill, we have from freshers to till level 10, level 1 to level 10. So we will provide this. We will provide this till the CEO level, fresher to till CEO level. We can provide this trainings on soft skill to develop their skills. So these are our clients who we are associated now and we are working. So these are our major clients. So I would like to end up my introduction part. So I would like to welcome our today's speaker, Mr. Jitendra Singh Tomar. So he is having a decade of experience, and he's a Microsoft certified trainer, and he's expertised in cloud technologies, and he's expertised in Azure, DevOps, Linux, PowerShell, Red Hat technology, and he had delivered many more trainings in various clients. And today's all agenda is all about what is DevOps, why it is required, what will all be impact within this production environment, and life without DevOps, how it will be. So this is all my presentation, and thank you all once again for joining this webinar. So over to you, Jitu. Thank you all.
Okay, thank you, Sugandhi. Thank you for the introduction. So, hello everyone. I welcome you all on behalf of Pioneer Business Solution. So let me quickly share my screen and let's begin with our content. So basically, we are here for the DevOps. Okay, DevOps is one of the most emerging technologies, most emerging method on which nowadays all the production houses, all the production companies are moving, which is basically one of the most important, and it has become the most important part of your production also. So basically, DevOps is something which all the organizations are uh, using, or they have started moving towards the DevOps. If they are not using till date, they have started actually moving towards it because it helps you in getting the things or getting your software released in a very easier manner, in a very smooth manner. So here, let's start with the presentation. Here we have what we had before DevOps. Okay, so DevOps is recently introduced. It's not been so long. Before that, also the softwares were getting delivered to the clients whenever they ask for the, however they are asking for to develop and deliver the uh, software. It is getting delivered, but there are several problems. There are several methods which the organizations were using, and they were facing the problem. One of the traditional model that they were using was the waterfall model. As name says, like how you have, if you have seen any waterfall, the water goes from top to bottom. That was the similar approach within this particular method as well. So it had multiple methods, it has multiple models where you will be working on each and every phase, and each phase can be only left and we can move forward for the next phase once the earlier phase, the previous phase is done. So here we had several phases like requirement analysis and specifications, design, implementation, testing, integration, and then operation and maintenance phase. So these are the several phases which are available. And if you are using the waterfall model, you will not be able to, or it becomes very difficult to move from the requirement phase to the designing phase and then go back. If you wanted to go back, then it becomes very difficult. Going from top to bottom, it is very easy. When you go for the requirement analysis, you gather all the information and done everything. Then you go for the designing phase. Then in designing, you realize, okay, I missed out this particular or that particular component. Then going back to the old step or old phase becomes very difficult. So that was the biggest problem with the waterfall model. Okay, and these were the different phases where in requirements and requirement analysis, you have to gather all the information, whatever is required. So all the features and functions will be gathered over here, whatever your software or whatever your application needs. Then you have the designing phase. So in the designing phase, we'll be talking about how the product is built, its layout, its architecture, everything will be discussed over there. In the implementation, we simply write the code, we implement it, and then we go through the several testing phases. There could be different types of testing depending upon what your product requires actually. So we have unit testing, acceptance testing, system testing, integration testing, and so on. So we select whatever is required for our product and then we simply deal with it. Then we have the deployment. So if all these things, if testing is done, then basically we deploy it under the integration part. We simply deploy that particular and see if everything works out. If everything goes good, then we deliver it to the client, to the end user. And then comes the maintenance phase, where basically after you release the product to the client, you do all maintenance and patching things and everything. So that is the simple waterfall model. With waterfall model, we had the other model, that is the agile methodology. In agile, basically what is happening is that you will be managing project by breaking it up into several phases. In agile methodology, we basically perform iterations. There will be iterations on planning, designing, development, testing. So all these things will iterate multiple times. So basically what we are doing the same job, we are developing the same product, but at every point of time, at every point of given time, we are basically iterating the particular code, and then we are reanalyzing that what needs to be rectified, what all things you have to, what bugs are there, how you can fix them. All those things will be done within this particular agile method. So it is the simplest and the most effective process to basically develop and deploy your software. But still, it also had some problems. This is the methodology which I was talking, that it will iterate multiple times. Okay, it will iterate. This iteration, it all depends on what kind of application you are preparing. It could be 3 iterations, 4, 5, maybe more than that as well. And every iteration requires the same amount of time, maybe 2 weeks, 3 weeks, 4 weeks, 8 weeks, depending upon what kind of application is being built. So these things will basically help you in understanding how the old methods were not completely capable of delivering what all things we want within the software development part. So to resolve all this problem only, we have got DevOps. So DevOps, as I told in the beginning, it is not a technology, it is methodology. It is a group of concepts. There are multiple concepts which are put together, and then simply multiple teams will work together, they will collaborate, and then they simply work on the entire software development. So basically, when I talk about teams, there are 2 teams we have. One is the developer team, and then we have the operations team. So this is what is written over here. DevOps is basically, it is the combination of 2 words, development and operations. So development team is basically responsible for developing, designing, and building up the application, whereas operations team will basically deploy and then do the testing job, whatever is required for that particular application. So basically DevOps is acting as a bridge between these 2 applications. Now, why it is happening like that? Why it is acting? Why is it something like, or do we have this now only, or it was there in the agile and waterfall model also? So yes, it was there in the previous models as well. But the biggest problem in agile was the 2 teams, developers and operation team, they will always have some sort of conflict. You might have heard this particular thing, boss, this application works fine on my machine. Then the other guy says from the other team, they say, no, it is not working on my system. It generally happens when you are not in the proper methodology, when you are having some sort of differences within the environment that a developer and a tester is using. These problems generally arises. I've heard this 1,000 times that it worked on my machine, but it didn't work on his machine. Why? That is the only reason. So DevOps is basically bridging that particular problem. It is making sure that you will have the ability to see through, to see what exactly is going on. Developers will be able to do their job properly. Operations team will be able to do their job properly. So this is the responsibility of the DevOps and its other concepts, which basically make the entire thing possible to work. So this is the universal diagram that you might have seen everywhere when we talk about DevOps. So this is actually an infinite cycle. If you see in your schools and colleges, you might have studied this infinity symbol. That is the same symbol over here. Okay, and this infinity symbol basically comprises of 8 different components. Starting from the planning phase, we plan the things. Then we have the coding. We code whatever we need. Then we build. Particular application, whatever you have done over here, it is getting built. After it is built, then we test it, whether whatever you built is perfectly working or not. Then it is released, then deployed, operate, and monitor. And if some problem is there, again, after taking the feedback, again planning, and then the same circle starts, the same loop starts. Now here the biggest part or biggest advantage of using DevOps is at every point of given time, the developer will know where exactly the problem is. See, in the traditional technologies, in the traditional methods, the developer has to wait. He has to wait till the entire the application is released, then the bugs will be found, then again the entire series will start. So it takes a lot of time to analyze what bugs we have and a lot of time to debug it also. In the traditional models, we had to actually sit and read the entire source code. The source code that you have written to build the application, you have to read it from the scratch. Now you all know, or you might have heard that it is not some 10 lines or 20 lines of code that you have to debug. Thousands of lines will be there. You need to basically find where the problem is, and then you need to rectify that problem. Then again, it has to be built, and then again it has to go through the same process. In DevOps, what exactly is happening is after every build, you have written a code and you have committed the code. You have saved the code, but whatever you have done, you have saved the changes. Immediately, one of the tool from the build procedure from this particular, it will understand, okay, there is a new change available. Now let me build it. The moment it built, immediately it will be tested. If everything goes good, it will be released for the next deployment. If there is a problem, then it will be again sent back. The feedback will be sent back to the developer. So after every commit, the developer is getting the report whether the application is successfully built or there is a bug in it. So at every point of time, we can find out where the problem is. Plus, DevOps also allow multiple developers to work together. So generally in productions, we don't write, or one single person don't write the entire software. It will be given to different teams. It will be given to different developers. So DevOps will basically allow you, or it will help you in writing it will be helping multiple developers to write their own code differently. And then once it is written, they can merge the code together. And here's the biggest advantage. The advantage is if you are not using DevOps, and then maybe there are three developers, developer A, B, and C. Maybe some developer B has done some mistake. There's a bug in it. So it is actually very difficult to find out who did the mistake. But if you are using the DevOps method, you will be easily able to track who did this and at what time he did this, he or she, whoever it is. So DevOps will basically help you in understanding and then it will help you in solving the problem as well. So these are the famous tools for the DevOps. So for planning, what I have done is I have taken this entire image and properly I've added them into different tabs so that you can understand how exactly things are going on, which tool will be used. So for planning and coding, we can use Git and Jira. For building, we have Apache and Maven Gradle. Then we have for integration, we have Selenium. For testing, for development, for monitoring, we have other tons of tools available. Now, these tools doesn't mean that it will basically help you in performing, or if you get expert to this particular list of tools, you become expert in DevOps. No, it is not like that. You have to be a knowledgeable person, or you have to know each and every tool, or at least most of them. Then it becomes quite easy for you to work with the DevOps. So basically in DevOps, we have 4 stages. Stage 1 is basically version control. So version control is nothing but you will be having different versions of your source code, which will be managed by any source code management tool. There are several tools, we'll be talking about them in a while. Like when I used to develop the things at that particular time, I used to make separate copies of each and every edit which I will perform. Not now, years back. I used to make different folders for each and everything so that I can actually save all the proper code. If it didn't work out, okay, my new copy, new replica which I have duplicated, that will only get disturbed. So again, I can go back and then do the job. In that, what I was doing actually, I was creating multiple replicas of the same project, which ended up in a big disaster when I accidentally I deleted few files from there. It was a big disaster for me. But here, if you do anything like that, we have different version control systems available, softwares available, tools available that will basically help you out in performing each and every change properly. You will have proper logs for each and every commit. When I say commit, basically whoever did the changes, whoever did the final changes to the actual product. So you will be having the name, the ID, and everything regarding that particular uh, source code. Then second stage is continuous integration. So basically in this particular stage, we compile, we validate, we do the code review, and then also we perform several integration testing, unit testing at this particular stage. Then we have third stage as continuous delivery. So CI, continuous integration is also called as CI, and continuous delivery is also called as CD. CI/CD. You might have heard this word multiple times. The CI is basically compiling and validating the code continuously, and continuous delivery is making sure that that you'll be able to deploy the build applications to the test server, perform the testing and all those things. So that is the simple purpose of continuous testing. Then you have continuous deployment. So basically you are deploying the tested application onto the production server for the release. And all these things are continuously monitored by some continuous monitoring tool. In short, also we call it as CM tools. There will be multiple tools available. There are multiple tools available which work out of which some will work for free. For some, you have to pay for the license fee. So we'll be starting with the first version control system, that is Git. Now, Git, you might have heard of it. GitHub, Git, you might have heard of this particular term multiple times. So what exactly Git is doing? It is a type of version control system only. Now, what is a version control? So basically, version control is a simple practice of tracking and managing the software changes in the software code. Whoever changed the code, at what time he changed the code, all those things will be logged with a snapshot of your, or you can say the backup of your previous commit as well. So in this case, let me take a simple example just to explain my point. So assume that you have created a file called A. You have created a file called A. And then a developer simply added few lines of code in this particular file. So what will happen? There will be a new file called B. But at the same time, my version control will be having the previous copy as well. So that if something went wrong in this particular, I have the old file with me as well. So this is the simplest explanation of what version control is doing. Next we have is the approach. What kind of approach a version control is using? So basically there are two types. One is the centralized version control system, and then we have the distributed version control system. By looking at the diagram, you can understand that there will be a developer called developer A, and he will be working with his own copy over here. On his own laptop, he'll be having his own local copy of source code, whatever code he will be writing. And then what will happen is he'll simply commit the code to this particular repository. Repository is nothing but the location where all your code will be stored. So the same thing can be now done for the developer 2 and developer 3 as well. And this kind of practice can be done with the help of a tool called as SVN. Then we have something called as distributed version control system. In this, what happens is you have the same thing, just a local repository on your own local computer has been added over here. So when in distributed, when the user commits any code, he will have his own replica of the source code, and then one more data will be basically stored over here in the original repository. And at any point of given time, the other developer also can pull the entire source code, and then he can also merge and collaborate with the developer A. So basically, version control is available in two different approaches. Either you can go for the centralized or you can go for the distributed, depending upon what your environmental requirements are. Generally, multiple organizations or most of the organizations are moving towards Git because it is quite easy to work, and here your data is safely stored as well. That is the reason people are using, or multiple organizations are using Git. There's no thumb rule that you have to use Git only. Again, it is all dependent on the requirement. So version control tools. So basically we have different version control tools available. We have Git, we have Subversion, we have CVS, also known as concurrent version system, and then we have Mercurial. So these are the four majorly used version control tools that you can use depending upon the requirement, obviously. But here mostly people are using either Git. Basically, it gives you a proper structure on how you can store the data, how you can retrieve the data from your repository, how you can merge, or how two developers can merge their source code and then deal with the actual source code. So all those things are actually quite easy and simple within the Git environment. Okay. Now, before we move on to anything else, I would like to ask a question. It is just a simple general question so that I can understand whether you guys are getting things or not. So here, basically, we have two things in Git. One is Git and the other one is GitHub. Can you tell me the difference between the two? Git and GitHub. Okay, I can see several answers. Okay, nice. So basically, Git is a version control tool. Okay, nice, nice. Thank you guys for responding so quickly. Nice. Thank you so much. So basically, Git is a version control tool that fetches the data, it pushes and pulls the data. Whereas GitHub is the code hosting platform. So it is basically a repository which is sorry, which is storing all your code in it. Great. Thank you so much. So next, so these are the several Git related commands. Okay. Git related commands where basically you will have several. See, when we start working on the practicals, at that particular time, we need several commands to create, to update, to upload the data, to download something. For all those things, if you want to perform within the Git, you need some set of commands. Those commands are simply categorized like this. So when you want to create Git repository, so you have a command called git init. Then if you have to make some changes, then in that case, we have several commands like state, add, and commit. For parallel development, also we have this entire category, and similarly for synchronizing the repository, also we have this category available. So depending upon what kind of requirement you have, there are several Git commands available. Obviously, I cannot show every command over here, but this is a generalized diagram that can basically explain how things are working within the Git operations. Moreover, it is all practical based. So whenever we connect for the practical session, at that time, we'll see how exactly we can deal with these things. Then we have the continuous integration. So basically, continuous integration is a practice of automating the integration of code. Okay, so here what you're doing is you're simply integrating the code developed by multiple people into one single software program. And to this particular point, the version control system, whatever you're using, it becomes quite important. It becomes the most crucial part of your CI, your continuous integration process. It will be fetching the code directly from the VCS, version control system, whatever you will be using. I am assuming that it is going to be Git for now. So my continuous integration tool will be fetching the source code from the Git, and then simply it proceeds further. So basically, CI or continuous integration is a development practice where the developers are required to make the commits in a very frequent manner. frequently the developers will be doing the commits, and then based on that, the remaining things will start. And every commit the developer will make, CI will pull that particular information, and then basically it will build a new, it will start the building part. It will build the code so that whatever problems, whatever bugs, whatever issues you have can be detected in the earlier stage only. So that is the reason why CI is very much required for your DevOps process. So this is a simple diagram which I tried explaining that what is happening when the CI, continuous integration, is not there. It's like life without CI for now. Okay, so you will be having in this phase, you will be having a set of developers who will be writing and developing the code. Okay, and then there will be some sort of repository. This can be anything. It could be local repository or any other shared repository as well. They will be making the commits. They will be saving the changes over here. Then based on that, either manually or automatically, you will pull the information from the source code and then test it. If there are no bugs, then simply you will release the product. If there are bugs, then the developer will be noted down, and then they need to find out, they need to read the entire source code to find out where the problem is. This becomes a big challenge when you have a huge application or a huge software to develop. And again, if some problem is there, then it becomes a very difficult phase to find where the problem is. So here, this is what we have already discussed. See, one thing I wanted to clarify in the beginning itself, guys. I generally don't prefer PPTs. So that is the reason whatever is written in the PPT, I am just telling it to you guys in the beginning. I'm not reading the PPTs. Don't worry about the data. The outcome will be shared to everyone once the session is over. So you will have all these detailed informations on all the topics and everything after the session is over. So please, you have to just focus it over here. That's it. So continuous integration, whatever I told is simply written over here. Now with continuous integration with CI, what basically happens? The developer will basically write the code, basically save it in the repository, the source code, wherever you are storing it. Generally, it is gonna be Git or SVN or whatever it is. Then my CI server, my continuous integration server, will pull the information, it fetches the information, and then it will perform building, testing, and deployment. Once these things are completed, then immediately the release will be done. Immediately it will be released. If there are problems within the code, then it will be immediately notified to the developer. And now this is happening after every commit. So assume the first commit happened, everything went well, no error, full notifications to the developers, no problem. Second commit happened, developers committed second time. In this particular phase, they found out that there is some sort of bug in the code, and that will be notified immediately to the developers. Immediately it will be notified. So now they know that where they have to target. What is their target area where they have to rectify the problem? Instead of rereading the same entire code from the beginning, they are just focusing on the only part which they have developed recently and committed. That makes the job of a developer much easier. And that is the reason why continuous integration is very helpful. So there are tools which will help you in performing the continuous integration. Like we have Jenkins, the most famous utility. I'm not saying it is the only one, but it is very famous. Then we have Buildboard, we have Travis CI, we have Bamboo. So there are different tools depending upon the requirement. You can use them depending upon the usage. You can simply use them. Now, it is also not mandatory that all the tools will be used. Again, it depends. Either one single tool will do the entire job. Maybe you require one or two more tools to work, depending upon what complexity you have for the application, what kind of complexity you are dealing with. Then based on that, you have to deal with the tools. Next is continuous delivery. So basically, continuous delivery is a software engineering approach where you will be delivering or where you will be producing the short cycles of your deployments. Whatever you have created, whatever you have built, you are delivering the small software, small releases. This makes my application, my software more reliable. It makes the building and the testing phase much easier, and with a greater speed and great frequency, we can deliver the product. So small chunks, you can say, small pieces of the applications will be delivered. This entire phenomena will basically help you in reducing the cost, overall cost. Okay, so this is all about the continuous delivery. So basically, continuous delivery has some mandatory requirements for the organization. Okay, you might have heard of something called as pipeline. So a release pipeline will be created for performing testing and staging and all those jobs. Once the entire application is built, then it will be tested, then it will be released. So continuous delivery CD will take care of all these things. Now also one more thing, continuous delivery will basically have, or you can say in easy terms, there are three different components within the continuous delivery, which will basically help you out in understanding and working with the application or the tool that you're using. The first is the visibility. The first component of your continuous delivery is visibility, where basically here you are delivering all the, you can say, you are building and deploying and testing, releasing, everything is happening in this particular phase only. And this entire part will be visible to the entire team. Whoever is part of that particular project, whoever is added to that particular project, they all will be able to see what all is actually happening. It will be visible to everyone. Then the second component we have is the feedback. So team members will get to know, or they will receive the feedback as soon as a build is complete. As soon as you are done with the testing part, immediately you will get the feedback. And in the feedback, everyone will be able to see where the problem is and where they have to work. And then the third part, the third component is continually deploy. So basically, throughout this entire process, you'll be able to release any version. There will be multiple versions that will be released. And then you can simply find out what exactly is the best application or best release for your environment, and then you can simply proceed further with the same utility. So here, continuous delivery will basically monitor, it will deliver, it will monitor each and everything at every point of given time. And that makes the deployment much simpler. So there are several tools for continuous delivery as well. We have Cradle, Jenkins, Buildboard, Buddy, and Apache Ant. So basically, these are the several tools. Depending upon the requirement, you can use either one of them or multiple. Again, depends on scenario, depends on the application that you have to use. Then next phase of DevOps is configuration management. Now, this is very important part when you talk about DevOps. Basically, configuration. Okay, let's ignore configuration management for now. Think if configuration management is not there. So first of all, try to understand what configuration management is. So it is simply a process that ensures that the product performance, functionalities, its attributes, design, everything is working properly and it is configured properly. So here, if you do not have a configuration management within your environment, you are still working on the manual implementations, you are still working on manual procedures, and you do not have the configuration management with you, then what will happen? So assume that your client suddenly says that, okay, I have a requirement of 10 VMs or 100 VMs, and maybe 100 is too much for now. Let's take only 10 VMs, that's it. But with those 10 VMs, what he did, he had sent the entire requirement that I want so and so things in those particular virtual machines or the physical, whatever machines he asked for. So now you have to do the installation completely, then you have to build the entire server according to the requirements, according to the specifications. And then you also have to install all the tools with the specific version and everything. For one machine, two machines, three, four, it is still manageable. If by chance they ask, okay, I need 20 VMs, 25 VMs, 30 VMs with the same thing, then definitely there are high risks of doing something wrong when you go for the manual work. So basically, configuration management will help you out in performing this kind of job in a very easier manner. There are several tools which will not only configure your virtual machines, your systems, but also they will help you in enhancing the performance and the functionalities of your systems. So here, basically, configuration management is a process of establishing and maintaining the consistency of products' performance, functional, and physical attributes with the requirements. The configuration management will take care of the entire attribute part, what all things you want. And also you can make track, you can track each and every change, whatever is done for that particular machine. If you have worked on Azure, in Azure we have the basic logs available. You can go to those logs and you can check what all things have what all things are implemented on this particular resource or resource group or any other component within Azure. Similar to that, you can track each and everything within this configuration management also. So basically, these are the several management tools which help you out in performing the configuration management in much easier manner. We have Terraform, we have Git, Chef, Ansible, Salt Stack, Puppet, and Docker. One of the most important and the tool which I trust a lot is Ansible and Terraform. I've practically worked on this a lot. I've worked on others also, but these are the things which literally helped me a lot in my previous organizations. Ansible basically is using, we have the Ansible component in few to discuss also, but I want to talk about it right now as well. So Ansible is something which you write, where you write some code, And that particular code, that particular playbook is then implemented on other machines. Now that code could be anything. You can simply modify the data. You can simply update the data. You can modify whatever you want over there. So basically, Ansible will help you out in performing this kind of bulk updations. Similar to that, we have Terraform, where you can simply build up your entire environment just on the go. You can write the entire program, and this is not only for one single cloud. Terraform is implemented basically for multiple vendors. Terraform can be used for multiple vendors. You have Azure, your Terraform for Azure. You have Terraform for AWS, Terraform for VMware, or whatever you want. Every big cloud vendor is part of Terraform nowadays. Now, what are the outcomes? What are the outcomes of a properly managed configuration if you have sorry, if you have created everything properly? So basically, when you talk about proper outcomes of your version, so basically, if you have written the configuration properly, then the automation that you are performing is gonna be errorless completely, or you can say there will be very minor errors that can be rectified. Once rectified, you can have the proper up and running production house. At any point of given time, you can scale up and then you can deploy that configuration to multiple virtual machines as well. For example, if I am running with a small environment where I have to do some automation, so completely I'm running with 10 VMs for now. Maybe in future I'm running with 100 VMs. So the same automation can be used for those 100 VMs as well. So basically, if you write the proper configuration, your work will become much easier. There will be less errors. There will be more, you can say, flexibility to your code. And all this thing can be achieved with the proper configurations. And you can use any of them. Here we have discussed so many. Here we have discussed with so many tools. It all depends on your environment, what exactly you want to use over here. You can simply go for either Terraform or Ansible. You can mix and merge both of them, or you can have Puppet, you can have Chef and Docker and whatever you want. So here it is all about the requirement. It is all about what you want within the production. And it is all about how easily you can adapt and then deal with these things. Then next is containerization. So before I move on, again, I want to have another question here quickly. What do you mean by a container? What do you mean by a container? Okay, I'm getting some answers. It's quite mixed answers. Okay. Cool. So basically, in containers, what generally happens is Okay, let me talk about first virtual machine, then it will be easier to explain what containers are. So when you talk about a simple virtual machine environment, what happens is you have your own hardware in the bottom. Let me show you the presentation. Like this. So here you in the bottom, you have your hardware. I'm talking about this virtual machine environment. Okay. So here in the bottom, we have hardware. Then on top of that hardware, you use hypervisor. What are hypervisors? Any idea? What are hypervisors? It's a tool. Yes, exactly. Someone wrote tool used for virtualization, which helps to do RDP. Okay. See, hypervisor is basically a tool that helps you in achieving the virtualization. Okay. In simple terms, you have VMware type, virtual server, VMM. Okay. So basically, if you want to understand what hypervisor is, it's simply a software. It's a tool. Now this tool is available in two different modes. If I talk about first mode, or which is called as type 1 hypervisor, type 1 hypervisor is something which will directly sit on top of the hardware. Means you have your bare metal hardware. Then on top of that hardware, you install your tool. Now that tool can be VMware ESXi, Citrix Zen Server, Microsoft Hyper-V, or any other third-party tool as well. And then these applications will allow you to install multiple operating systems, and then you can install multiple applications on it, and then you can simply work with it. Now, here basically what happens is in this particular type 1, you directly install the application operating system on top of the hardware. I told there are two types, type 1 and type 2. Type 2 is basically you will be having your hardware, on top of your hardware, you will be having your operating system. And then on top of operating system, you will install the hardware, hypervisor. Hypervisor installed on top of the operating system comes under type 2. Now this can be seen directly into your Windows 10 operating systems also. If you go to your control panel, add and remove features, then you will find there's an option called Hyper-V. If it is not there, because some of the editions does not support it, if it is not there, then you can install VMware Workstation on your machine. You can install Oracle VirtualBox on your machine. But ultimately, it is also doing the same job. On top of that, you install your application and then you install your operating system and then you install the application and then deal with it. This entire is the virtual machine environment. Now, think you're talking about installing an entire operating system over here. What is going to be the minimum size of this particular virtual machine or this application? It will be in GBs. If it is a Windows machine, then minimum 32 GB is itself required for the operating system. If it is a Linux machine, minimum 5 to 8 GB is required. So we are talking in GBs over here. It is a big environment. If you install any application on that, if you start working on that application, then it requires other things to deal with your hardware, and then you have to do a lot of things over here. When you talk about the containers simply contains all the common libraries and the tool which is required to run those applications. In one single container, it will be having all the application, its libraries, its DLL files, everything under one single package. And it will, the overall size of one single container will be in MBs. So you can see the difference. From GB, we drop down to MBs. That makes my application much faster and more stronger, more reliable. Your application will basically have all the things which are required and it will be packaged. It will be packaged in one single container and then you can use it or your colleagues can use it in the same way how you have deployed it. So that is the biggest difference we have here for virtual machines and containers. So containerization is a form of virtualization. Okay, so basically containers are lightweight, portable applications, you can say in short, that will have no conflict when you run it in multiple environments. When you run this in different setups, there won't be any conflicts. The best word here we have is the lightweight. The size of the container is gonna be very small in comparison with the virtual machine. So difference we have already seen. What is the difference between a virtual machine and a container? Okay. Now, here one thing you have to remember regarding the containers. Okay, so here applications run in an isolated manner. Okay, here in containers, in containerization, application runs in a very isolated manner where it will be having more security. It will be very hard to crack and it will be very easy to build as well. That is the simplest explanation of what a container is. Benefits. So we have several benefits of using the container. One of them is great consistency. So basically container make things much easier for all the teams. Let it be developer team, let it be the operations team. Cost saving. If you compare it with a virtual machine, it requires less memory, thus less cost. We're talking in terms of GBs and MBs. One same application can be accommodated within few MBs, maybe 10, 100, 150, whatever MB it is. And the same application, if you're running in the virtual machine, will go in GBs, 30 GB, 35 GB, 40 GB, maybe more than that. Okay, so here next is security. So containers, as I told you, it is isolated. So two containers won't communicate or don't interact with each other. So you have a very proper up and running container. If because of some reasons, if something goes wrong with your container also, so your tool, your containerization tool, whatever you'll be using, will try to self-heal that particular container. In virtual machine, we do not have the healing capacity, but containers does provide the healing capacity as well. Next is the agility. So the containers are completely portable. I can create one container on my machine and I can upload it somewhere. It's a hub where you upload all the containers which are used by Docker, called Docker Hub. You upload all the images over there. And if any other person on the other end of the world is sitting and requires the same thing, they can simply download my container and then start working on that container itself. So they don't have to build everything from scratch again. That makes my container much portable. Simply the same container can run on any platform. Let it be Mac, let it be Windows, let it be Linux. It is not at all your application, your operating system dependent. because you are on the top of the operating system, you're installing the tool, and then inside the tool, you are running that container. Next phase is the continuous monitoring. In continuous monitoring, basically, it is a process of continuously identifying, monitoring and identifying the threats to your software cycle and entire architecture. Any type of problem, any error, any warning should be captured then and there itself. And that is the job of the continuous monitoring and its tools. So basically, this is the last process. If you remember that infinite symbol, this monitoring was the last procedure of or last stage of the DevOps process. In this particular, everything, any running application will be monitored. Its attributes, its resources will be monitored. If any problem is there, immediately it will alert the developer or whoever is maintaining that particular application. Immediately it will be an alert will be sent to these particular teams. So when you talk about the continuous monitoring, there are different types of monitoring that can be done. You have infrastructure monitoring, application monitoring, and network monitoring. So when you talk about infrastructure monitoring, so basically here you are gonna monitor components like storage, hardware, to be more specific, servers availability, disk usage, CPU usage, what the runtime processes. If any error occurred, immediately it will be alerted to the required team, concerned teams. Storage, permissions, all those things will be simply monitored under the infrastructure monitoring category. Then you have application monitoring, which is basically providing the details about the application. Its uptime, security, logs, everything. Even application monitoring tracks the SLA, service level agreement, between the buyer and the vendor. Basically, you are gonna monitor the entire application under this particular category. Then we have network monitoring. So this particular is gonna basically monitor switches, servers. So whatever is related to the networking part, those things will be monitored under this particular category. We have different tools also for the monitoring. But for each type of monitoring, I have categorized several tools over here. So for infrastructure monitoring, we have something called as Nagios and Prometheus. Nagios is something which comes under two categories: Nagios Free and Nagios, or Nagios Core and Nagios XI. Nagios Core is completely free. You have to set up each and every component by yourself within your environment, but it is free. Then Nagios XI is something which is more towards the graphical part. It is a web-based tool. You can perform everything on the web browser. Every process is the automated process, and it is paid. Again, depending upon the requirement, you can simply work with that. Similarly, we have application monitoring. So under application monitoring, we have something called as Splunk. I've actually worked with Splunk. It is one of the best monitoring tool I have ever seen in my life. Maybe I completely agree. There may be some tools which is better than Splunk. I completely agree with that part. But I have never seen anything like Splunk. The reason why I'm saying that Splunk is something which fetches each and every report in much detailed manner. You want to talk about virtual machines. Every virtual machine every RAM, CPU, hard disk, anything, even logs can be monitored for each virtual machine. Even if you have one VM, you have 1000 VMs, Splunk doesn't matter, it will monitor everything. Firewall blocks, generally this is a common problem in production houses. You have to allow the firewall, you have to allow a particular port in firewall. Maybe you are not aware that it is opened or not, you can simply use Splunk for that. Like that, there are multiple applications with Splunk, multiple applications of Splunk that you can simply just discuss for hours and hours. I wanted data last year at this particular date or within this particular range between this time. What happened to my machine? How will you find it out? If your Splunk is configured properly, you can have it. You can create your own dashboards within Splunk. Multiple teams can create multiple dashboards and then deal with it. Like database team, they can deploy their own dashboard page, which will be monitoring all the databases are running or not, all the applications are responding or not, what is the IO on each and every server. All those things can be monitored, can be managed on a granular level. Then we have the network monitoring. So one of the monitoring tool is Wireshark. The other one is Nmap or network mapping. OK, so again, these tools can be used accordingly. You can install them on your machines, then you can simply play around with them. But these tools can help you in the entire procedure of your DevOps process from the beginning till the end. After the product has been delivered, even you will be able to monitor each and everything. You'll be able to trace any errors, any warnings are there. These applications will basically find out and then alert to that particular concerned teams. Then the next part of our presentation is Docker. So basically, Docker is the simple platform as a service. In cloud, you might have heard of this particular term called platform as a service, or also we call it as PaaS. So platform as a service is nothing but you will have less data to manage on your end. You will be actually managing only the application and the data. Remaining thing from the infrastructure, server, networking, storage, middleware, runtime, applications, everything will be managed by the vendor itself. That's the simplest explanation of what platform as a service is. In platform as a service, you don't have to manage much things. You have to just manage only the data. So as in the Docker. In Docker, you'll be able to perform something called as containerization, or what we have studied earlier. In Docker, simply you have the containers, the isolated containers. You can build your application. You can package your libraries and configuration files and everything. And then you can use it for yourself. You can share it with others on Docker Hub. So it is all done, or it all can be done with the help of Docker. So it is an open platform for developing, sharing, and running applications. So basically, it is a quick way to deliver a software in much easier manner. So what are the benefits of Docker? Basically, it is fast. It is very fast. Once your Docker is installed on your machine, it becomes very easy and very quick to deploy your applications and test them immediately and then release it as well. Okay. So basically, when you talk about benefits, Dockers are quite fast. They are much responsive and they can simply run more load on the same hardware where the virtual machines, like for example, if I have two identical machines, machine A and machine B, they are completely identical. On machine A, I will run containers. On machine B, I will run VMware. On machine B, I will run virtual machines. Hardly 3 or 4 virtual machines I can run on machine B. But if I talk about containers, depending upon the size of container, the size of the image that you're using, I'm taking a standard size, so it will be like 9 to 10 images can be executed parallelly. So it gives much more faster and reliable way to work on Docker. So this is the basic Docker architecture, how basically the entire Docker works out. So we have something called as Docker client over here. So it is simply the primary way where you will be installing Docker and you'll be simply interacting with the applications. Then on Docker host, this is basically the Docker host where you will be having multiple things. You can see here you have something called as containers, you have the images. Images are nothing but you can say the lightweight operating systems. So you are pulling the operating systems from the registry. There are global registries available on the Docker Hub website. You can pull any image of your choice. Let it be Ubuntu, CentOS, Nginx, or any other application as well. That image simply can be pulled into your own Docker, and then you can simply start building your own application. You can start preparing your own containers within your environment. And if required, you can then upload the same updated or modified image into your account as well. And you can then make it public, or you can leave it private only where the organization colleagues can use it. If it becomes public, anyone in the world can simply download that image and then deal with it. So Docker basically gives much more better experience to deal with how the application built is happening, how you'll be building up the application. Then next we have is Kubernetes. So it is nothing but a portable, extensible and open source platform. So basically, whenever you have multiple, like you have container workload, then in that case, simply we go for the Kubernetes. When you have a very large environment, a very large containerized environment, you want to deal with it, you want to manage it, each and everything, you want scaling should happen on containers, then in that case, you can simply go for Kubernetes. So basically, it has a large, rapidly growing ecosystem. Kubernetes is one of the tool which is used widely among the production houses. It automates your operational tasks on the container. Whatever operational tasks you have for a container management, basically Kubernetes will help you out in that. Including you want to deploy application, you want to roll out some changes, you want to scale the application, you want to monitor something, can be done with the help of Kubernetes. So this is what is written. Kubernetes basically automates the operational tasks like deploying application, roll out the changes, scaling, and monitoring. Scaling can be done on Docker also, but it is much difficult sometimes to manage Docker Swarm. So basically, people jump for the Kubernetes because it is much easier to handle and manage containers within Kubernetes. So this is why we should be needing the Kubernetes. So you have the traditional environment, traditional deployment over here, where you have the hardware. Then on top of that, you have the operating system, and then you run multiple applications. Then you got the virtualized deployment, means the virtual machine, and then you have the containerized deployment, where you will be having an container where multiple containers will be running over here. And if you want to manage this, manage these multiple containers, then Kubernetes becomes very handy in these situations. Okay, so basically containers are similar to the virtual machines only, but they have their own isolated operating system. Everything is gonna be the, you can say it is gonna be a very lightweight application, lightweight software. Next, we have the benefits. So you can automate the operations. There are several commands where you can simply automate your day-to-day applications. Then you have the Kubernetes handle compute, networking, and storage workload in much easier manner. So your infrastructure can work in a very smooth way. And then you have the monitor service health monitoring. So anything can be monitored under Kubernetes. Everything. Every container can be monitored under Kubernetes. You can monitor each and everything. You can perform the health checks. You can, if in case something went wrong with a container will try to fix it. It will restart it. Whatever is required, it will try to heal the container. So this is what you should be knowing about Kubernetes. So can you guys, before we can move on to next slide, can you guys give me the difference, like whatever you have understood between Kubernetes and Docker? Can you give me some of the difference between Docker and Kubernetes? What could be the major difference? Okay, a few people have asked the same question in the chat also. Fine, no problem. I will only respond back. See, when you talk about, okay, some people are writing it. Okay, cool. So when you talk about Docker, so basically what Docker is doing, Docker is automating the deployment of the application. Here in Docker, it is deployed as services. In Docker, the apps are basically deployed as services. There are no default auto scaling feature available. The health checks are very limited to the services. Whereas when you talk about Kubernetes, the Kubernetes is maintaining and managing the deployment of the containers. Basically, all the containers can be managed, deployed, monitored within the Kubernetes. Now here applications are deployed as a combination of deployment services and something called as pods. Then in Kubernetes, you have the auto scaling feature within a cluster. Kubernetes also perform different kind of checks, health checks, you can say. The only thing is in the beginning, when you talk about the initial phase of Kubernetes and Docker, Docker is really easy to set up and install. Kubernetes on the other hand is quite hard. It is quite difficult to manage and do the entire installation and setup. But once this is up and running, things become very easy. Kubernetes will basically help you in managing. Kubernetes will basically help you in managing multiple clusters, multiple applications in much easier manner. with multiple health checks. On the other hand, Docker has the similar things, but in a very small scale. Next is IAC. So basically IAC is nothing but infrastructure as code. Basically, it is the approach to manage your data center, server, storage, networking infrastructure. So it is all about the infrastructure. If you want to manage, you want to deploy, build, and perform anything, IAC is gonna be very helpful to you. Basically, here, whenever you have to deploy a larger scale, larger configuration, larger scale you have within your environment, then in that case, you can simply go for the infrastructure as code. All the configuration basically are stored in the normal standard files, which will help you in performing the configuration in a easier way. And basically it improves the productivity overall. So whenever you have the whenever there is a chance to basically deploy a big environment, you have a big management to do, or you need to update anything, you need to create an entire environment on the go in a much easier manner, then in that case, we can simply go for infrastructure as a code service. And to basically do that, we have several tools available. We have Terraform, we have CloudFormation, we have Azure Resource Manager templates. We have Google Deployment Manager, we have Ansible, Chef, Puppet. All these things are available to perform basically the entire modification of your environment. Whenever you want to scale it up, you want to manage anything, these things will basically help you out. We already spoke about Terraform in the beginning. Terraform will basically help you in creating, like for example, if I have a requirement where I need to build up the entire infrastructure. Maybe manually, if initially I want to do it manually. So I want to deploy my own network, I want to deploy my own storage, I want to deploy my own VM, then attach my network to the storage. Manually, it can be done for one VM, two VMs. But regularly, if you have to do it on a larger scale, then it becomes quite hard. It becomes quite difficult. So here what you can do is you can simply go ahead and write the Terraform query, the entire code you can write, and then basically it will help you in populating in whatever environment you want. Let it be Azure environment, AWS, VMware, or any other environment also. HashiCorp Terraform supports a number of products. Only the way, or you can say the syntax remains same. The program code will change a bit. Rest everything is gonna be same. So if I change something, if I write a code for AWS, I can do small changes and then I can deploy the same code for Azure or any other platform as well. So here the main question comes is, what is the difference between infrastructure as code and automation? Basically, here in infrastructure as code, you are basically dealing with maintaining the configuration. And in automation, you are just pushing the code and pushing the different state, whatever you have written within the environment, within the script, you are pushing it to the multiple resources. So here IAC plays an important role when you have to configure applications, configure environments in bulk. At that time, this becomes quite important. IAC becomes quite important. Tools, this we have already discussed. Ansible. I told you that we'll be talking about Ansible in a while. So here Ansible is basically a simple tool where you write a particular script and then you run it on multiple machines. Now that script could be used or created for anything. You can use it for configuration management. You can use for application deployment, application installation. You have any network automation you want to allow, you don't want to allow. Anything can be done with the help of Ansible scripts. Basically, Ansible will make any type of change that you want on the remote machines, on the multiple machines. Here, when you talk about the Ansible working, so here you have one single Ansible server where you will create something called as playbook. So playbook is nothing but you can say set of codes written in specific language, that is YAML, YAML, yet another markup language. You use YAML to write the Ansible playbook. And then basically you deploy this playbook on the inventory. Now inventory is nothing but the group of computers. Either it could be one computer or it could be 100, 100,000, whatever it is. The same exact action will be taken on all the machines. And here Ansible will basically try to connect using the SSH protocol. Ansible server will try to connect to all the clients on the SSH protocol port number 22 only. That makes my configuration much secure. So whenever you want, like for example, I want to patch, just a simple example, I have 100 machines and I want to patch it. Like in my old organization, we had a patch cycle which comes out after every 3 months. After every 3 months, we have to patch nearly 4,000 to 5,000 servers. We have to. That was the policy. Now, imagine if the same thing needs to be done manually. It can be done manually, but imagine if you have to do it actually manually, one by one, go to each and every server and then deal with it. It becomes a nightmare. So what we do, we create an Ansible server, we write the Ansible script on it. That's Ansible script is basically called as playbook. We write the Ansible playbook, and then in whatever host inside the inventory, you basically write the computer names where the deployment needs to be done, where the patching needs to be done. Rest will be taken care by the Ansible itself. So this is the simplest working of the Ansible playbooks. So as I told you, Ansible playbook, it is written using the YAML script. It is very simple to understand, human readable structure. Clearly, very easily it will be written over there. So anyone who has little knowledge on programming, they will be able to understand how things are going on within the playbook. It becomes quite difficult. See, I have written here, playbook can be simple if you are just deploying few things. You're installing an application, you are changing some permissions, or then it is easy. But when you start using loops, variables, it actually becomes quite complex. So even if you have to deploy patches on Linux machine on your ESXi hosters, then also the Ansible playbook can be very helpful. If you go to VMware account on GitHub, there are patching scripts, Ansible playbook patching scripts available, which you have to just download, keep it in your repository, run it, and your ESXi host will be patched. Firmware, BIOS, or whatever patching needs to be done, it will be upgraded. So for that, Ansible playbook is quite easy option for us. Next application or next tool we have is the Puppet. So Puppet is also a configuration management tool. It helps in managing the configuration, but it follows the client server model. Means, or client server can, here also you can call it as master slave model. There will be a Puppet server, Puppet master, and then there will be nodes, or you can say Puppet slaves. So you write the Puppet script, you write the script on the Puppet master, and then basically you deploy them onto your nodes. Anything that you want to configure can be done easily with the help of Puppet. Maybe you want to deploy, you want to copy, simple example, you want to copy an application from your machine to 100 servers. You want to modify something from your machine to 100 servers, or maybe more than that. I'm taking 100 as a simple example. Basically, Puppet will help you in fetching and then running those applications, those scripts onto the nodes, onto the end nodes. There are basically two versions of Puppet, the open source Puppet and then the Puppet Enterprise. So when it comes to the open source Puppet, it is the tool which is directly from the website. You can download and start using it. You can go to Puppet website, download the code, and then start working on it. And then you have the Puppet Enterprise, which is a commercial version. Basically, that will offer multiple things like reporting, orchestration, RBAC, role-based access control functionality, maybe GUI and API access as well. So everything can be done with the help of Puppet Enterprise, but again, it is licensed one, it is the paid one. And when you talk about the Puppet master slave architecture, which I spoke in the last slide, it is this master slave model. So basically, there are a few things that you should be knowing. Like when you talk about the server side, on server, we have something called as manifest. You might have heard of this word manifest somewhere. This is actually the code which you write so that this particular code can be deployed. The manifests are actually code for configuring your clients, your slaves. Then the other keyword we have is the template. That is the combination of data and the code that you have written. When you talk about the client side, we have something called as agent, which is responsible for interacting with the master server continuously. And then we have something called as fact or factor, which is responsible for collecting the information of your current machine, of your current server. Okay, so this is what the proper Puppet architecture looks like. There will be a master server, and then there will be some slave machines. Master server will have something called as manifest. Manifest is nothing but the code. If required, we can also create several files over here with the templates. This file can be easily downloaded onto the end nodes, and then these nodes can simply use it. These slave nodes can use them. Now, whatever we have studied till now, it all fits under one single diagram. If you look at this particular diagram, multiple things are written over here. Like for planning and coding, we have something called a continuous deployment, which is working over here. For building and testing, we have continuous testing. For integrating, after monitoring if any bug is there, if any problem is there, again the planning starts. So for integration, we have the continuous integration available. For deployment of operate, we have the continuous deployment, and then for monitoring, we have the continuous monitoring phase. All these things, this entire infinite cycle keeps on working. It keeps on running, and it will be doing their own job depending upon what kind of application you have installed. But one thing I want to make sure that you have to work with multiple softwares in this particular DevOps process. If you become one single, if you work with one single application, like for example, Git, you can't say you have become the DevOps engineer. You should be knowing multiple things over here in order to deal with it. See, it is not mandatory. I have seen people who knows only two things: Git, GitHub, and Terraform. That's it. These people also call themselves as DevOps engineer, and it is true. It is correct also. But if you have to be successful in this particular field, then in that case, we require knowledge on all or at least most of the applications. You should be properly known to how the coding and the planning and the coding phase is gonna happen for CD, for CI, what all things will be needed, how the pipeline is gonna work out, how, or at least from the basic, if you have to write a simple Git code, how you're gonna store it and how the other person is gonna fetch the same code, or if not person, how the tool, continuous integration tool is gonna fetch the commit from that particular Git account and then process and build the code for build the uh, application for me. So all these things needs to be done on a very simple phase. Okay, simply these things. Today we have just discussed about the theory part, because taking all the modules practically it's not possible within 2 hours. But definitely if we go through the practical again, that is at that particular time, I'm not going to run these PPTs anymore. Only the practicals will be there. You will be only working on how to, from the scratch, how to basically write a simple code in Git, how to upload it, even how to install that also. All these things from the basic you need to understand and then deal with it. You need to work with it. So that's all from my end. So if you guys have any questions, you can ask me. Thank you, Naveen. Guys, please don't leave the session. Okay, session is over, but there are a few more things that needs to be discussed. Please, for a few more minutes, stay with me. Thank you, guys. Thank you for your comments. Yeah, I'll be sharing PPTs, not exactly the PPT, but the PDF I'll be sharing with you guys. This PDF will be having all the information, what is needed, whatever you guys can do, what all things we have already covered. Few more additional things are there. You guys can simply take the advantage of it. See, in training session, we will be, yes, going in depth. I told you, see, no one in the world, I can challenge, no one in the world can complete entire training theory and practical in 2 hours. It is impossible. Okay, so in training, yes, if we go through that, we will go through each and every module, whatever topics we spoke, like Git, We have talked about Git. We spoke about Puppet, Ansible, Chef. We spoke about Docker. We spoke about other tools, Nagios, monitoring tools, Nagios, and Map. So many things are there. If not all, maximum will try to cover it up so that you can understand how things are actually going. We'll see from the beginning phase till the end how once the application, once the developer has written a code till the end, how it is getting monitored within the Nagios will be seen practically. And if I'm saying this, that starting and ending will be shown to you, then obviously we have to talk about the middle sections as well. The technologies that will be helping the code build, test, verified, whatever is used in middle, even we need to talk about them as well. Okay? So we will be talking a lot. We'll not talk a lot. We'll do the practicals a lot once we have the opportunity to work with these things. Any tentative dates? Sorry, I cannot specify any tentative dates, but if you have sent your email ID, then definitely you can expect the email from my colleagues that we are going to have so and so seminar or webinar and so training at this particular date and time. Or continuously, you guys can you can visit to Pioneer Business Solution website. I'll share the link in the chat. So you guys can, if you have any queries, this is the mail ID, please make a note of it. You guys can drop a query at any point of given time. And this is the website where you can simply jump and search for any queries, any trainings. We have open house trainings, we have open house sessions, multiple things are there. Please go through the website properly. You will understand in a much better way. And we have shared one feedback form in the chat window. Please fill that feedback, then only you should be leaving. OK, don't leave it like that. First of all, fill the feedback, whatever is your view, whatever is whatever next technology you want. Please fill that feedback form. That will help us for the next trainings.